All right, so we're going to start talking about functions, and we're going to be looking at today specifically whether something is a function or a relation. So the definition of a function is a relation with one or more variable where each input, this is where I'm going to use some different colors, so where each input has a single output. Okay, so a function is a relation where with one or more variable where each input has a single output. Now, since we use the word relation in our definition, we should make sure that we define that as well. So I'm just going to put that here at the top. And a relation is just two sets of numbers. And these numbers can be given to you in different ways, but anytime you have two sets of numbers given in a mapping form or a graph or a table, you have a relation. And then some relations are also considered functions, and that's where the input has a single output. So you can think about the function machine, and you've probably seen these when you were younger, and the input is what goes here. That's what goes into the machine, okay? The input. And then what comes out is, of course, the output. Right, so you put something in, something happened to it, something else comes out. There are other terms that we can use to describe or refer to the input. One of them is domain. So when we talk about the domain of a function, we're talking about the input. This is your x value. So if we're looking at ordered pairs, the x value is going to be your input value. And it is also the independent variable. Okay, the independent variable. And I remember that because input and independent variable both start with IN. So these are all different terms that you'll see for the input. And these values cannot repeat. Okay, so input values cannot repeat for a function, right? For a relation, you can have as many repeats as you want. All right, so the output is also going to have corresponding terms. So where the input was the domain, the output is your range. So domain and range go together. The input is domain, the output is range. These are going to refer to the y value. So if you have an ordered pair, the y value is your output value. And this is referred to as your dependent variable. And that's because in order to figure out your output, you have to know the input. So the dependent variable is found based on what's happening to your input. So those are some terms. The output values can repeat. So this is a little bit confusing sometimes, but the output values can repeat. Okay. So those are the different terms we're going to be using when we're talking about functions. Okay. When you have a function, okay, each x value is only allowed to correspond to one y value. Right, so this is going back to that x's cannot repeat, input cannot repeat, output can repeat. So let's look at a few examples. If you look here, this table is showing a relation, and it is a function because none of the x values are repeating. Right, so 0, 1, 2, 3, 4. In the second example, this relation is not a function because one of our inputs has two different outputs. So in this instance, when x is -3, y is 1, or x can be -3 and y be -1. So when that happens, we have a relation, not a function. Okay, let's do a few more examples on the back. So determining whether it's a relation or a function. When you have a table, you're going to look at the columns. The relation will not be a function if any x values correspond to more than one different y value. Then you have two examples here, A and B. In A, check and see, do any of your x values repeat? And in B, do any of the x values repeat? In A, the x values do not repeat. This is a function. In B, the x values do repeat, so this is not a function. So the x values repeat and have a different y value. Set notation is when you use brackets and parentheses and points are separated by commas. It's really important that you use your parentheses and your commas when writing answers in set notation. Here, review the ordered pairs. The relation will not be a function, again, if any x coordinate, when it's written as an ordered pair, we refer to it as an x coordinate, corresponds to more than one different y coordinate. So if we look at C, 3, 4, 2, none of them repeat. It is a function. 1, 0, 1. 1 and 8, 1 and -3. That's not allowed. This one is not a function. Okay. When we have a graph, we can use what's called the vertical line test. The relation will not be a function if a vertical line ever touches two or more points on the graph at the same time. So if you take your pencil or ruler and you go from left to right over the graph, here, even though it's a curve like this, that's okay, we don't touch more than one. So this one is going to be a function. Here, you can see that if I put the pencil down or the pen down, I do cover multiple spots, same x's, different y's. So this means it is not a function. All right. And then finally we have a mapping diagram. And here the mapping diagram, you're going to look at your arrows. It will not be a function if any of the x values maps to more than one different y value. So if we look, one arrow, one arrow, one arrow, one arrow. Since each number only has one arrow from the x value, this is a function. Here, the 3 has two different arrows going to different y's, so this is not a function. So to recap, a function is a relation where every input has one output. X's cannot repeat, Y's can repeat.